Hi, I want to talk to you guys today about dot and decimal conversions. And so this is very important when you're working with memory addresses or you're working with IPv4 or IPv6. Essentially what you're given is you're given four different octets associated with IPv4, and you have to convert the dotted decimal to hex, or you have to convert the dotted decimal to binary. So in the case for IPv6, we look at binary. For the case for IPv6, we look at hex. For the case for IPv4, we look at binary. If you're looking at memory addresses, specifically how it's stored, such as 2's complement, you're looking at hex. So let's go into a simple example. Over the course of the next couple of months, we'll go through many examples associated with firewalls and different IP addresses that are on your network looking with Nmap. But in this scenario, I want to do a very simple example. So in each IPv4, you have 4 octets. One octet is 8 bits, or 8 different slots. And so we're looking at 107. And so let's look at binary first. So in our first octet, we have 8, 6, 7, 8. And we're looking at 107. So on the very right side, it's 0 to 1, 2, 4, 8, 16, 32, 64, 128. And what helps me is when I split it down the middle, on the right you have 8, on the left you have 16. And that really helps you cut down dotted decimal conversion to binary from 90 seconds to 30 seconds. And so in this scenario, you're looking at 107. 107 is greater than 64 and less than 128. So in this scenario, we want to have 64 in there. And so we could put a 0 right there. So we have 64. The next slot is going to be 32. And so 64 plus 32 is going to be 96. And so we can take that in to consideration and use it because it's less than 107. Our next slot is going to be 16. So if we add 16 to this, it's going to be too much. It's going to be 112, and we're looking to get 107. So in this case, or this scenario, you can skip it and put a 0 there. Our next one is going to be 8. 8 plus 96 is going to be 104. That's less than 107, so we can use it. Then we come to 4. 4 is going to be 1 too much, or 1 too many, and so we can put a 0 there. Our next one is going to be 2. 2 is going to help us get closer to 107, and so we can use it. Lastly, we're just looking at 1, and that's going to be the last slot. So there's our conversion to binary from dotted decimal, which is 107. You do this procedure or process for each of the octets associated with IPv4. IPv6 is a different beast, and so we're going to look at the standards associated with IPv6 addresses and how the actual IP address is broken down into its different components. However, that's going to be a different video because that requires a little more thought and that requires a little more structure. Right here, we're just going to be concerned with converting it to hexadecimal. And hexadecimal is special. So instead of having each slot being a factor of 2 or a power of 2, or in this scenario, being able to use natural numbers associated with dotted decimal. Now we're looking at hexadecimal that is going to be a factor or power of 16. So let's get rid of this binary problem and let's talk about hexadecimal. Hexadecimal goes up to 16 for each slot. And depending on what your memory address is or what you're looking at, you can have multiple slots of hexadecimal characters. In IPv6, we're really concerned about getting to 128 bits, and we'll talk about how many hexadecimal characters are associated with each slot within IPv6, but it's really going towards the future, and it's now a federal standard as of December of last year. So as mentioned, federal agencies now require IPv6. It's important to use. Now we're going to look at how to convert 107 to the hexadecimal representation of its value. It's important to note that up to 9, you're going to use regular integers, but after 9, you start using letters, and so each letter after 9 is associated with essentially 10 plus its natural position, and its natural position will be 0. So in this case, you have 10 for the first natural position, and then you have 11, then you have 12, 13, 14, 15. And what's important to note for IPv6, just like when you're looking at decimal and when you're looking at binary, is that you can essentially decompose the number into different powers associated with whatever base you're using. So in this case, we're using base 16. And so the first position is going to be 16 to the power of 0 times the number of that slot plus 16 to the power of 1 times the number of that slot. And this can go on forever, and that's what memory addresses do. They keep tacking on more and more powers of 16 to get a better representation for larger numbers. So in this scenario, let's replace the pound symbol with the actual number to make it 107. So how I come up with the conversion is I pick a number that is smaller than 107 unless it's exactly equal for the first position. So the first slot, if we were to pick, let's say 7, well, 7 times 10 is 70, and then 7 times 6 is going to be 42, so you have 112, and that's going to be one factor too large for 107. So go one below that, and let's do 6. So 6 times 16 to the power of 1 is going to be 96, because you have 6 times 10, which is 60, and then 6 times 6, which is 36. You add those two together and you get 96. So essentially this first slot is going to be a 6. So we have to come up with a number that is going to be the differentiator to make it 107. So in this case, it's an easy subtraction to come up with the number. And what's interesting about this scenario is we're going to need 11 to get to 107. But 11 is not represented in hexadecimal by 11. Instead, it's represented by B. So in this scenario, you're going to have the letter B there. So if you were to see this within an IPv6 address, now this is just part of the address, and this is just part of a section of the address. But essentially this would be represented as 6B. A lot of the computer science majors and computer science documents use 0x6B to represent hexadecimal. Essentially, this is telling you that it's a hexadecimal number and to use it as a hexadecimal number. Once again, this was the dotted decimal conversion to binary and the dotted decimal conversion to hexadecimal. This is important, and you'll see that it's used for IPv4 and for the video I made with that. I'll be making an IPv6 video very soon to help tag along how to use hexadecimal conversions and hexadecimal characters within its representation. Once again, I thank you for watching the video and I look forward to seeing you on my channel. Have a great day. Bye.